Hello everyone, welcome back to my channel. Today let's go over a medium level question that I just solved on my own. So I'm super happy about this and I'm very glad that I was able to come up with my own solution to this question without any assistance. So let's go over it and let me show you how I did it. So this is question 3815, design auction system. So basically, you're asked to design this system managing multiple bids, and you have these methods that you need to implement. So basically, let's just go ahead and implement each one of them. So we're going to probably need a dictionary because we're trying to track a bid for a user ID and item ID. So let's call this a default dict of type integer, as it can take composite keys. And then for adding the bid, let's just say self.d user ID and item ID is equal to the bid amount, right? We're trying to overwrite as well for add. If it already has, then replace it with a new bid amount. And then the update bid is the same thing. User ID, item ID is equal to new amount. And then for removing the bid, it's pretty easy. Again, these are the composite keys. So we're just going to delete that user ID and item ID from the dictionary, since dictionary keys have to be unique. And then for getting the highest bidder, again, just return the user ID of the highest bidder for this item ID. So let's just say, first of all, if the dictionary is empty, then return -1. Otherwise, let's loop through each key value pair. And let's just say if the item ID matches, which is A1, the key's first index is equal to the item ID we're looking for, and the basically now we're trying to find the biggest user ID and the bid itself. So let's create a sorted list. And then we're just trying to say sl.add the actual, so the user ID is there, and we're just trying to add the user ID, which is A of 0, and then the bid itself, which is B, right? That's the value of the key. This is the key itself. It can be a composite in this case. And then at the end, if the sorted list is empty, return -1. Otherwise, return the rightmost element, because we're looking for the user ID. And in this case, it actually happens to be index 0, since this is the value itself. And so let's run this. Okay, wrong answer. Let's see. So of the highest bid, so we probably want to prioritize sorting by bid order first, and then we can return the user ID itself, right? The highest user ID for the highest bidder. Cool. Let's submit this. And what you'll notice is this is going to time out because this is n by itself. So there's definitely a quicker way to do this, and I'll show you the way I came up with to optimize this. So time limit exceeded. And the whole idea is to basically track this information as we update or remove or add. Okay, so let's create another dictionary called self.h, and we're going to make this one a default dict of sorted list, because this time we're only interested in the item ID. So we can just say, and we have to update. So first of all, this might already be in the dictionary. If it is, then we're trying to remove this and then update it with a new amount, because it might have existed from before's update. So the whole idea is the bid amount is going to be the value if it exists in the dictionary, and this default dict API takes care of that. So basically, for this current item ID, let's go ahead and discard, which is removing the bid amount and then also the user ID. So we're going to store the bid amount and the user ID in the same order as we're doing here. And then here for updating, same thing. Again, if it already exists, then we're going to update that value. So let's say we have like 5, 7 as the values in this dictionary. We're going to replace that, because if this is already used, then we're just going to, for example, replace it with 5 or whatever the new value is, and then insert it again. So self.d or self.h of item ID, we're going to add the new amount, which is the bit amount. This is the old one, this is the new one, and also with the actual user ID. Cool. The item ID is the key, right? So then here, same thing. We're going to update it, but first we need to discard it. So self.h of item ID, we're going to discard the old bit amount and user ID if it exists from the list. So we're going to have, for example, 3, and then we're going to see like 4, 7, 6, 8 or something. And if this exists, then we're just going to discard it. And then we're going to update it again. Let's say for 8 this time. And so that's how this sorted list is going to work, the value of this item ID key. Okay, so next, again, we have to add the new amount this time and the user ID. So the new amount this time is probably going to be different. So if we had 8.5 before, we're removing that, and then maybe like 8.6. And then keeping this in sorted order too, so that would go here. So that's what this and this does. And then here, removing is pretty simple. We just want to, using the item ID, discard the actual user ID and then the bit amount. The bit amount, again, being self.d, user ID, and item ID. So now in this case, this makes this easier because we don't have to scan over again. So if not, and let's call now is going to be self.h item ID, the actual, this part. And so if not now, then return -1. Otherwise, return now the rightmost because it's already in sorted order, right? Because we're looking for the user ID itself, which is going to be index 1 here. And it's ordered by the amount and then the user ID because we're looking for the highest bidder as well. Okay, let's run this and submit it. Okay, so it's not correct. Let's see what's going on. Okay, so again, we're removing and then adding. Removing and then adding, and we're just removing here. Okay, let's print now. Let's print the dictionary as well, just to make sure we're on the same page. Okay, so there's something wrong because the dictionary is not reflecting what this is. So the bit amount and the user ID was added in that way. So maybe we could say if I don't think this matters is in self.d, then we do that, but don't really think that's because the default dict already takes care of that. Okay, so it's supposed to be -1. Okay, so updating the bid. Let's check our work again. So the user ID and the item ID, discarding the actual bid amount. And then the user ID, setting it to the new amount. So looks correct to me. Perhaps we could make this a sorted set. I'm not sure if that really matters. Probably doesn't. So again, we want them to reflect the same thing. So I don't know what's going on. So here, the value itself. Let's print self.d and self.h. Print self.d, self.h. So we already have a mismatch here. Oh, bit amounts and then user ID, wrong order, right? Okay, so let's try this again. Okay, and this time let's submit it. Output limit exceeded again. Okay. And there you go, passes all test cases. So again, I'm super happy that I was able to come up with my own solution to this question without any assistance and solve it completely on my own. So that's it for this video, and thank you for watching.